Here in Tollymore Forest, there was a series of structures, all different. There was 2 gates, a fountain and 9 bridges and some other bits and pieces of follies that needed repaired. Our task was really to survey each structure, see what needed to be done in the short term and long term in terms of repairs, and to then specify the work required to deal with those repairs. This is the Ivy Bridge. This was one of the better bridges. So what we did here was we were able to find that the 4 towers had remnants of a lime plaster which had almost disappeared. We applied a whisper coat to the existing towers, and the reason it's so white is because it's lime and sand. There's no cement in the mixes. This whisper coat is thrown on in a traditional manner using a spade, using a coal shovel. That's how it's thrown on, and it just brightens the towers from the rest of the bridge, and that's all it does, and it weathers the stone slightly. And there was 1 or 2 of the pinnacle stones loose. There was an iron cramp buried in there. We took the iron cramp out and just rebedded it on a stainless steel cramp which won't corrode. In this case, there was so much ivy on the stonework that the ivy had really got into the joints, open joints in the rubble stone, and as it had grown in, it had pulled the stone loose and moved mortar. So the mortar that was holding the stones and the very, very small pinning stones, it had started to move those out, and that allowed the bigger stones to move out then. So the ivy really needed to be cut back fairly dramatically, and any loose stones then built in again. Some of this work, it's not only about knowing what you're doing, it's knowing when to stop. So removal of moss, the removal of ferns is really not what we tried to do. It's just the invasive plants which are going to cause a lot of damage. They need to be brought under control. What we're trying to do is just conserve enough, but without leaving too much of a footprint. We're at Follies Bridge. The issue here was that some of the smaller pinning stones had dropped out, and rainwater was able to penetrate down through the wall thickness. And key to this bridge is this pattern of big stone, wee stone, big stone, wee stone, big stone. The big stones are obviously the most important element, but the small stones are driven in to hold the big stones in place. And once they become dislodged and fall out, then eventually the bigger stones become dislodged, because this falls out, rainwater can then get down in, and it washes out the mortar below the big stone. Then the big stone becomes loose. Eventually it topples off, and then the wall starts to disintegrate. So the small stones are important, and with that, when you're bedding them, use an aggregate, a mortar with a good size aggregate, so that they're properly held in place. See the bigger stones? These stones can be anything up to 1/3 the size of the joint, just to control the shrinkage of the mortar and to give a good bedding for these bigger stones, so that the water can flow away from the top of the bridge. So to use a finer mortar without aggregate, the mortar would have failed over time with frosts and thaw action. It would have started to splinter and peel away the mortar, and would have failed. Each bridge would originally had a soft verge, and that verge was there to allow water to be slowed down, and then it percolated down through the stonework. But a lot of these bridges have had a concrete or asphalt or gravel surface put on them, which means the water gets to the edges of the bridge much quicker than it was originally designed to do. So what happens is that the verges need to be kept under control, taken away, so the water can get away effectively away from the bridges, because if it gathers, then it runs down through the core of the outer walls of the bridge. So keeping the verges under control is important. The bigger bridges, which were subject to a lot of vehicular traffic, they had originally had water chutes which allowed the rainwater to flow off the top of the bridge, and then there would have been a foot on the other side of the water chute which threw the water clear of the bridge, so the water didn't just spill down the face of the bridge. Over time, these chutes got covered over with, as the ground levels rose and rose and rose, the chutes got blocked, then the water had to travel through the bridges. What we did, we found these chutes because we knew they were there, and we reinstated the chutes so the water could get clear of the bridges. The first folly that everybody sees when they come in here is the entrance gate, which is the Barbican gate. It's a fairly rustic structure, a fairly robust structure, but rainwater had started to enter into the top of the stones, and there had been some repairs carried out in the past which had started to fail, and all of that was allowing weeds and vegetation to gather and start to break down the pointing. After we'd surveyed it, the repair was a series of some render repairs and some pointing repairs, and where stones were loose on the crenellations on the top of the towers, we lifted those stones and rebedded them on a lime mortar so that they were secure again. The obelisk, now it had suffered corrosion of its iron cramps, which was causing the stones to move, and so that was taken down from top to bottom. All the stones were numbered carefully so they didn't get jumbled up, and then the structure was rebuilt to its existing form. Every stone was in the exact position it was taken out of, and we introduced stainless steel cramps rather than iron cramps, so that the issue which caused the deterioration in the first place has been attended to.
This is the old one that was put in with lead. It's rusted away, you know. So when it rusts away, then the stone gets loose, you know. They loosen up. They're used for keeping the stone from spreading out, you know. They're all the way up. They're all tied in, so they can't really go anywhere, you know. And then the old one would have been put in with lead, been set in, and then hot lead poured over them, and melting lead. And these is put in with a chemical, come out with a tube now and just squeezed in, and it's hard and tightens up in 10 minutes. But the stainless steel, that'll never rust again, you know. When we came to work on the Horn Bridge, it was slightly different from every other bridge. It had originally been rendered, unlike almost all the other bridges which were just pointed with stone. A lot of the render had started to fail, but we decided we'd only patch repair the render which had really failed, and not a wholesale renewal of the render. Again, where render had failed into the quatrefoils, which is the carvings, we cleared that out because rainwater was gathering on the flat surfaces and then penetrating down through. So we benched those out with mortar so that the water was thrown clear, and where ivy and vegetation had accumulated on horizontal ledges, we cleared all that as well. When we came to work on the Hermitage, we took a slightly different view. It's a very romantic structure, and so we didn't want to remove so much of the vegetation and the ivy that we left it very bare and desolate. So we only took away the vegetation that was causing problems. So there was 4 or 5 beech saplings growing through the roof. Clearly we took those out and killed the roots, but everything else we just left as it was. The repointing was kept to an absolute minimum. We didn't really want to deface the structure too much. The Bransford gate, it's a fairly detailed structure, very robust, but had suffered a lot of decay with rainwater coming in through the top of it. Also, it had been repointed in the past with a cement strap pointing, which was causing damage to the stone underneath. So it was important to get that strap pointing out and to repoint it with lime and to reset stones on the copings which were loose. There was a lot of stone decoration missing, bop finials. They had been broken off down through the years and had just gone missing. So we reintroduced those stone details. As you come to Tollymore now to visit, the greatest hope that we have is that you won't notice that we've been and done some work, because that was the aim of this, to do enough to conserve these bridges but not to make it absolutely obvious that someone had been. So the greatest thing is that you won't notice that we've actually done anything.